Hello everyone, it's Prodie and welcome to 0.3. This topic really shouldn't exist, okay? I'm really sorry, it was my noob recording and I actually forgot to include it in another episode. It should have been explained in the Information in Electronics episode, but of course, I am a noob at recording. I'm a complete noob and I did forget to record it in that episode, so I'm really sorry. On the bright side though, you do get another episode for free, really. No cost at all. I mean, not that any of my videos should cost. Well, we probably should get straight into it and not get sidetracked like we did last time. So I'm going to start referring to, the heads and tails that I explained in the information and electronics videos. Well, I'm going to change those to kind of no voltages, or I might describe them as ones and zeros, however I feel. But ones and zeros, one would mean voltage, zero would mean no voltage. That's probably how I'm going to start referring to these heads tails combinations. So in binary, there are different columns, like in a normal number system, where you have the units column, the tens column, and the hundreds column. Like in the units column you have 1, 2, 3, 4, 5, 6, 7. In the tens column you have 10, 20, 30, 40, etc, etc. In binary, we have quite similar columns, only the columns are, instead of tens column, the hundreds column, we have the ones column, the twos column, the fours column, the eights column, the 16s column, the 32s column, etc, etc, etc. This goes on ages. It keeps doubling, as you might have noticed. But they're only going to stop, really, when you're satisfied with the number that you've obtained. So if you want to have, I don't know, a few million, you're going to have to keep doubling until you get to a few million, and then you can make the number with that many columns. These columns might actually not make that much sense to you, because of course you have ones column, twos columns, four column. What's that supposed to mean? I mean, where's the tens column, and the units column, and the hundreds column? Well, all you need to know is what I've told you. You don't really need to understand it at this point, but you'll be fine. I will explain what all these columns mean, but you'll be fine for now as long as you understand the different columns that you can have. Ones, twos, fours, eights, etc, etc. So here's what I mean by the columns. First of all, the way that you represent 0 in binary is 0, 0, 0, 0. That is, none of the columns on. Here there is no value, and so the ones and zeros show 0. So that is all of the ones and zeros. There's no ones, there's just zeros. That way you get 0. This is like in base 10. If the units, tens and hundreds, etc., all show 0, then the value of the number is 0. So, for example, in base 10, if you wanted to show 19, you have a 1, then a 9. If you wanted to show 0, you'd have a 0 and a 0. The 0 and the 0 are exactly the same in binary, and that's all I wanted to say there. To show a 1 in binary, however, it's 0, 0, 0, 1. This is also like base 10, because the units column would show a 1. Things only really start to get different when we decide to make numbers that are bigger than 1 or 0, which is, of course, most of the time. We're not going to be dealing with 1s and 0s for the whole of our lives. So to make 2 in binary, it's 0, 0, 1, 0. This is different to base 10 because in base 10 it would just be 0, 0, 0, 2. The reason that it's different and we don't use 0, 0, 0, 2 is because there aren't enough outcomes per column. There are only 2 outcomes per column in binary. We only have an on and an off for a wire, so it can only show a 0 or a 1. But the 2 in binary we don't actually have space for, because we're counting in base 2. We only have zeros and ones. Where would the 2 fit in? Well, we're going to move it over to the 2's column. If you wanted to display a 3 in binary, it would be 0, 0, 1, 1, because the 2's and the 1's column are both on. If you have a 2 and you have a 1, then you get 3. So both are needed since there's no 3's column. There's only a 1's, 2's, 4's, 8's, etc. As you know, we've missed a 3, and so we have the sum of the 2's column and the 1's column to make the 3. There's also a 4's column, so 4 in binary would be 0, 1, 0, 0. 5 would be 0, 1, 0, 1, which would be the 4 plus the 4's column plus the 1's column. That does in fact make 5. this is probably a bit difficult to understand at the moment, and I understand that. I found it quite difficult to understand when I first learned binary. It's one of the hardest things you need to know to get into computing at a basic level. So I'm probably going to be going over this in the next slide as well, just to give you the gist of counting in binary. So here's a list of different numbers, and I want you to see if you can see a pattern. I'm going to go through them step by step, but if you start to get a feel for it and you think that you understand how this strange, whatever language this is, binary, you probably have no clue what I'm talking about. But if you start getting an idea about how this works, try and figure out each of the numbers. Try and figure out past 13. You probably need more bits, that is more columns, but try and get past 13. So I'm going to start with explaining 0. 0, 0, 0, 0. None of the columns are on, so you don't have a 1 in either of the columns, you have 0 value. Makes sense. 1 would be 0, 0, 0, 1. The 1's column only is lit up, and so... Lit up? What am I talking about? I say some strange things, I'm sorry. But in the 1's column, for 1, the 1's column is the only column that actually shows a value. That way, all we have is 1. For the 2's column is all that shows a value. For the 3, well, we need the 1's column and the 2's column, and that makes 3. So 1 and 2 make 3, because there's no 3's column. 4, 0, 1, 0, 0, because the 4's column is all that shows. For 5, we need the 1's column and the 4's column. So as you know, 1 and 4 make 5. I hope that you can get the same conclusion. If not, you might need to go over maths just one more time. For 6, 0, 1, 1, 0. You need the 4's column and the 2's column. And as I think you know, 4 and 2 are 6. Again, if you don't know that, you might need to go over maths one more time. 7, 0, 1, 1, 1. That is the 4's, 2's and the 1's. That's 7. If you add 4, 2 and 1. For 8, 1, 0, 0, 0. That is the 8's column is lit up, because you do actually have an 8's column. Remember what I said about the columns? They double. You get the 1's, the 2's, the 4's, the 8's, the 16's, the 32's, the 64's, the 128's, 256, and I don't know past that value. 512 actually. But the point is they keep doubling, and you've got to use a combination of these of these ones in these columns to make different values. So today we learned how to write numbers in a foreign language. Don't worry if you didn't get it. This won't be the first time that I go over this topic in a video. Almost every time I use binary, I'm going to try and go over what we discussed in this video. If binary really does seem like a foreign language today, then it will seem like second nature very soon, so long as you stick with my channel. Next time we're going to go over some basic designs for arithmetic circuits, and we're going to go over how they look. So I hope you've enjoyed, but more importantly, I hope you've learned.